10 years ago, if you had told anybody, except maybe Elon Musk or a very dedicated SpaceX employee, that SpaceX in a decade would become the largest launch provider in the world, launching far more rockets than even the People's Republic of China could, or Russia, or anybody else. If you had also told those people that SpaceX would launch as many as 2 rockets in a single day, reusable rockets that could land themselves, well, I'd say most people, if they cared about you anyway, would have referred you to a psychiatrist. And who would have blamed them? In 2013, SpaceX had yet to reach orbit with a Falcon 1, not a Falcon 9, and their dreams of reusability seemed worlds away at the time. And also, the only way to get human beings into space was through the Russians, and that would remain the case for half a decade afterwards. A very long stretch of time where we were exclusively dependent on Soyuz rockets, not on rockets from SpaceX, in order to get Americans, Europeans, anybody else into space. How things have changed. And because things have changed this radically, it's also very important to note just how vital SpaceX has become to NASA's future plans, especially when it comes to Moon to Mars. A lot of you may not know that NASA actually has a plan, a multi-point plan for getting the human race not only to the moon, but also to Mars. To the moon to stay, and perhaps the same thing for Mars in the future. There are many, many aspects to this plan, many things that are going to have to go right in order to make all of this possible, and so many of the points of this plan are completely dependent on SpaceX, and not just Starship, Falcon 9, Falcon Heavy. So many things that SpaceX does are absolutely vital to the success of this plan. Without SpaceX, if SpaceX does not remain a thriving and successful company, then everything NASA has in mind for the future is absolutely going to fail. So we're going to check out NASA's plan in depth, how SpaceX fits into that, and also, before we go any further, please subscribe. I am so close now, less than 4,800 subscribers away from that magic 100K, which is going to make a huge difference to my channel. If you haven't subscribed yet, and I know there are thousands of you who watch every one of my videos who haven't subscribed yet, please do so now. Costs you nothing, and it would make a huge difference to me. Let's get on with NASA's plan to get us to the moon and Mars, and how SpaceX fits into the whole thing. Now, this is a 63-point plan. I'm not going to go through all of them. I'm just going to kind of hit the high points. But the first of these points is actually something that SpaceX doesn't have anything to do with, which is a good thing because NASA is doing a lousy job on this first point. International collaboration. Partner with the international community to achieve common goals and objectives. As some of you may have noticed in a previous video that I released on this subject, NASA has been doing a wretched job of collaborating with Europe, Japan, and other nations in order to establish clear objectives and responsibilities for other countries, which is absolutely brainless because there's only so much money to be spent on the Artemis program in the first place, and if ESA and JAXA are willing to pick up a lot of the bill for a base, for example, which is what you're looking at right now from the European Space Agency, efficiency, it would save NASA an insane amount of money in their long-term ambitions of establishing a permanent presence on the moon. And aside from a base, here's some other things that other countries are bringing to the table. For example, launch vehicles capable of resupplying the lunar gateway or bases on the lunar surface. In addition to that, lunar rovers. JAXA has had a proposal for a very ambitious lunar rover for a very long time, and also, assuming the H3 rocket eventually gets off the ground, will have the capability of delivering it to the moon. Now, of course, both the Ariane 6 and the H3 are not reusable and therefore will not be as efficient or cost-effective as SpaceX's various vehicles that NASA employs, but it doesn't matter if Europe and Japan are picking up the bill. Sure, it's not the most inexpensive way to go, but if you're not paying anything for it, then you have no reason to complain. Now, the third, fourth, and fifth point of this plan all have something to do with SpaceX. The first of these is crew return, returning crews safely to Earth while mitigating adverse impacts to crew health. Then crew time, maximizing crew time available for science and engineering activities within planned mission durations. And then maintainability and reuse. Well, you can practically define SpaceX by maintainability and reuse. And then as far as crew return and crew time is concerned, all of that is going to depend very much on the success of Lunar Starship. And then there's interoperability. Enable interoperability and commonality, such as technical, operations, and process standards among systems, elements, and crews throughout the campaign. Given the fact that SpaceX is going to be taking care of so many aspects of the Artemis campaign, it's going to be very important that all the rest of the technology that NASA employs is compatible with what SpaceX uses. And of course, SpaceX is going to have to make modifications to their own equipment in order to make it compatible with NASA equipment. For example, the ability to dock with the Orion spacecraft in lunar orbit, and the ability to dock with the Lunar Gateway as well. And then there's the point of leverage low Earth orbit. That is to say, leveraging infrastructure in low Earth orbit to support Moon to Mars activities. That infrastructure can be summed up in two words: LEO refueling. That is the most important piece of infrastructure that's going to have to be built in low Earth orbit in order for Moon to Mars to be successful, especially a permanent presence on the moon. Resupplying and delivering things to the moon with one launch at a time from SLS isn't going to work. We're going to need to build a robust refueling infrastructure in low Earth orbit in order to get supplies and personnel to the moon on a regular basis, and of course, SpaceX is going to be the best qualified to do a great deal of that. And also, it's very possible that other launch providers may be able to make use of this same refueling capability. For example, Vulcan Centaur, the Centaur upper stage, is also designed to be refueled. So let's move on to some other points. The next several points are almost tailor-made for SpaceX. To develop cislunar systems that crew can routinely operate to lunar orbit and lunar surface for extended durations, develop systems that can routinely deliver large surface elements to the lunar surface, develop systems to allow crew to live and operate safely on the lunar surface and lunar orbit for extended periods of time with scalability to continuous presence to visit areas of interest for scientific research, conduct Mars analog activities, support industrial utilization, and conduct utilization activities, and then to develop a habitation system for crew in deep space for extended durations, enabling future missions to Mars. All of those points are perfectly fulfilled by Starship, and very little is in development that could do this aside from Starship. I mean, when it comes down to it, really NASA should replace their wording that they use in this plan with develop Starship. For example, develop a transportation system that crew can routinely operate from the Earth-Moon vicinity to Mars orbit and Martian surface. In other words, develop Starship. Develop a transportation system that can deliver large surface elements from Earth to the Martian surface. In other words, develop Starship. Develop systems for crew to live, operate, and explore on the Martian surface to address key questions with respect to science and resources. In other words, develop Starship. Really, there are few things that NASA has in development, or any other company or nation for that matter, that is going to be able to fulfill these requirements of NASA's plan better than Starship, or even be able to fulfill them at all. And the points just keep coming. Develop systems capable of returning large cargo mass from the lunar surface to the Earth, including the capabilities necessary to meet scientific sample return objectives. Develop systems capable of returning large cargo mass from the Martian surface to Earth, including the capabilities necessary to meet scientific sample return objectives. Again, develop the Starship. Of course, there are infrastructure requirements for both the Moon and Mars in this plan that really can't be fulfilled by Starship alone, although some people think that Starship should be used as a lunar base or a Martian base. I oppose that notion simply because I don't like the idea of throwing a Starship away. It's a reusable vessel capable of carrying hundreds, if not thousands, of tons to other locations if you keep reusing it, while if you use it for a base, you've pretty much lost it, and 2/3 of the ship isn't even suited for a base anyway. It's comprised of fuel tanks and engines. Not really the best thing to have for a lunar base. However, everything that's required to build lunar infrastructures, and also infrastructures on Mars, such as this amazing Mars ice house, can be more easily facilitated by Starship and its massive payload. So let's go through the next 7 points. Number 1, develop an incremental lunar power grid that's evolvable to support continuous human robotic operation and capable of scaling to global power utilization and industrial power levels. Can't really build a power grid without a large amount of payload to deliver it. Develop lunar surface, orbital, and lunar-to-Earth communications, position, navigation, and timing architecture capable of scaling to support long-term science, exploration, and industrial needs. Now, that isn't Starship in itself, but it sounds a lot like Starlink. Starlink, established in a network around either the Moon or Mars, could take care of all of those things. Then demonstrate autonomous construction, precision landing, surface transportation, industrial scale in situ resource utilization, and advanced manufacturing capabilities in support of future continuous human lunar presence and a robust lunar economy. You're not going to build a robust lunar economy without lots of payload. Also demonstrate technology supporting cislunar orbital surface depots, construction and manufacturing, maximizing the use of in-situ materials and support systems needed for continuous human robotic presence. And then once you've done all of those things, you essentially duplicate it on Mars with the next 3 points. Develop Mars surface power sufficient for the initial human Mars demonstration mission. Develop Mars surface, orbital, and Mars-to-Earth communications. Develop and demonstrate entry, descent, and landing systems capable of delivering crew and large cargo to the Martian surface. Now, there are operations objectives as well, and all of these are designed to establish a routine operations procedure on the Moon before we try to do the same thing on Mars, and it's very thorough. For example, conduct human research and technology demonstrations on the surface of the Earth, then low Earth orbit platforms, then cislunar platforms, and then finally on the surface of the Moon to evaluate the effects of extended mission durations on system performance, reduce risk, and shorten the time frame for system testing and readiness prior to the first human mission to Mars. Then you optimize operations, training, and interaction between the crew, the support team on Earth, orbital support, and a Martian surface team consisting of communications delays, autonomy level, and time required for an early return to the Earth. Space SpaceX is going to have to be seriously involved in all of that because they're going to be providing much of the transportation for the human crews between Earth and Mars, or indeed even Earth and the Moon. Yeah, sure, SLS may handle some of that at the beginning, but in the long run, let's be honest with each other, SpaceX is going to be handling these things. Also, the plan includes mastering in situ resource utilization operations. In other words, to master the process of converting lunar ice into usable fuel and usable oxygen, usable water for that matter. All of that is going to be very important if we're really going to be successful in a mission to Mars. Without in situ resource utilization, a mission to Mars is going to be practically impossible. Also, to establish command, control, and coordination of processes that will support expanding human missions at the Moon and Mars, operate surface mobility systems using EVA suits. SpaceX may even be involved in the EVA suit side of things, given the fact that SpaceX intends to carry out the first ever private EVA excursion sometime this year. So they may take care of the spacesuits as well. And then on top of that, you also need to evaluate, understand, and mitigate the impacts on crew health and performance of a long deep space orbital mission, followed by partial gravity surface operations on the Moon. Once again, SpaceX providing a lot of the transportation for the astronauts, therefore they'll have to be involved in that as well. Validate readiness of systems and operations to support crew health and performance on the first human mission to Mars. Demonstrate the capability to find, service, upgrade, or utilize instruments and equipment from robotic landers or previous human missions on the surface of the Moon and Mars. Yeah, they even intend to cannibalize some of those landers and rovers that we put down on Mars in the past. I'm pretty sure that particular objective may have been inspired by The Martian. And then there are a lot of things involved with robotic systems as well, which really don't have anything to do with SpaceX, such as demonstrating the capability to remotely operate robotic systems that are used to support crew members on the lunar or Martian surface from the Earth or from orbiting platforms. And once again, I think that's something that really validates the importance of the Lunar Gateway, or indeed a base on Phobos. You're going to need to be able to operate robots in real time, and that's something you can't do from the Earth if you're talking about robots on the Martian surface. Now, there's quite a number of science-related objectives, unsurprisingly, built into this plan that don't have a lot to do with SpaceX, aside from their ability to deliver a lot of scientific equipment to anywhere in the solar system once Starship becomes operational, so I'm not going to cover all of those points, but I'm going to summarize them real quick. There's exploration science, which is to conduct science on the Moon and in cislunar space using integrated human and robotic methods and advanced techniques to address high-priority scientific questions about the Moon and to demonstrate methods for future science by astronauts beyond the Earth-Moon system. Once again, even if we're talking about science-related objectives, it's Moon to Mars, and the most exciting thing about it, astronauts are built into every single bullet point, a huge departure from what NASA has been doing for the last half-century. Then there's lunar planetary science goals, which are to address those high-priority planetary science questions, which are best accomplished by on-site human explorers on the Moon and Mars, aided by robotic systems. Human beings, astronauts taking the lead at last. Then heliophysics science, address those high-priority heliophysics science and space weather questions, which are best accomplished using a combination of human explorers and robotic systems on the Moon and in cislunar space. And then biological and physical science goals, which are to understand fundamental biological effects when organisms are present in fractional gravity and deep space environments, to gain new scientific understanding and information to guide system development. In other words, How well do human beings and other biological organisms hold up when they're exposed to cosmic rays, radiation, and microgravity for extended periods of time? And then finally, astrophysics science. Preserve the far side of the moon as a radio-free zone for future radio astronomy experiments. If we establish a radio telescope on the far side of the moon, it will change our understanding of the universe forever. So that's the plan, and when it comes right down to it, SpaceX covers the vast majority of the objectives in 3 out of 4 categories: transportation and habitation, lunar and Martian infrastructure objectives, and then finally operations objectives. Only the science objectives falls outside their purview. Although Europe, Japan, and other countries may be able to assist when it comes to resupplying astronauts on the moon or perhaps even Mars, and also establishing infrastructure on the moon, those sorts of things, SpaceX is going to be handling the lion's share of it, whether it be resupplying astronauts on the Lunar Gateway with Falcon Heavy, delivering astronauts to the lunar surface with Lunar Starship, or in the long run, delivering astronauts to Mars with full-fledged Starship. I really don't see how this is going to go any other way, at least not affordably, which means let's hope that the relationship between SpaceX and NASA and between Elon Musk and NASA remains a cordial one. 10 years ago, when SpaceX was on the verge of bankruptcy, it was NASA funding that came after Falcon 1 successfully made it to orbit that kept this organization going. So in my opinion, this is a partnership that's going to last for a long time to come. My deepest thanks to Nick Henning 3D, who provided this amazing animation of Lunar Starship. Please check out his channel and subscribe to it. Please turn on those notification bells, subscribe to my channel, and like this video. And until the Moon to Mars plan comes to a successful conclusion, I urge all of you to stay angry about space.